So, section 3 of chapter 5, what we're going to be looking at is centripetal force. Now, centripetal force deals with Newton's second law, which states that whenever an object accelerates, there must be a net force to create that acceleration. And the equation pertaining to this is the centripetal force equals the mass times the velocity squared over the radius. When we look at the direction, the centripetal force is the same as the centripetal acceleration, in which the force always points towards the center of the circle and continually moves as the object moves. Now, force required to keep an object mass of m moving at speed v on a path radius r. We're going to look at conceptual example 6 in the book. In a circus, a man hangs upside down from a trapeze, legs bent over the bar and arms downward, holding his partner. See figure 5.7. Is it harder for the man to hold his partner, A, when the partner hangs straight down and is stationary, or B, when the partner is swinging through the straight down position? So, the picture, this is the picture of the trapeze artist, a visualization of it. So, the correct answer is it is harder when the partner is swinging through the straight down position. And the reasoning behind this is whenever there is motion in a circular path, that means there is a centripetal acceleration. And because there is a centripetal acceleration, that means there is a centripetal force required to produce this centripetal acceleration, which is Newton's second law. So, obviously, it would be harder for a person to hold his partner if he needed to exert a force on that person. When the partner hangs straight down, he's not exerting a force because the partner is not moving in a circular motion. That is why it is harder when the partner is swinging through the straight down position. And I wrote down the reasoning: man must exert a centripetal force. Now, check your understanding question. A car is traveling at a constant speed along the road A, B, C, D, E shown in the drawing. Sections A, B, and D, E are straight. Rank the acceleration in each of the four sections according to magnitude, listing the smallest first. So, we're going to do a little visualization of this. DE, the centripetal acceleration is going to be 0 because it's moving at a constant speed on a straight line. So it's going to be 0. And the same can be said about AB on the top. It's the same exact situation, so the centripetal acceleration will be 0. Now BC and CD, they both will be greater than 0. However, BC has a smaller radius. Therefore, its centripetal acceleration and centripetal force will be larger than CD with a larger radius. So the order that we have: 1, ranking the smallest first, AB or DE, 2, CD because of the bigger radius, and 3, BC would have the largest because of the minuscule radius in comparison to the others.